One of the most useful rules we do all year is on page 151 here. So again, if you speak French, you're going to say this a lot better than I am. It looks like it's spelled El Hospital, but I believe it's pronounced, does anyone take French before I say this wrong? No one's going to jump on me? I believe it's pronounced Le Hôpital. You don't say the S, I believe, in the French. L'Hôpital.
That's wrong.
Come on, shut up, Luke. All right, so revisiting an old friend. So if we were to go back to limits here, what do we do with this for? What's our first method? What do we do? Plug it in. So we're going to get 16 plus 8 minus 24. 4 squared is 16 minus 16. So 16 plus 8 is 24. 24 minus 24 is 0. 16 minus 16 is 0. And this had a special name, 0 over 0, we called indeterminate. Okay. So when we tackled indeterminate, that just meant you had to go back and do something else. What could you do with the top and bottom here? You could factor and simplify, right? So indeterminate is 0 over 0, and it meant you could do something else. So when working with limits, our first approach is to attempt direct substitution. However, direct substitution often leads to this indeterminate form. Okay, so we have to do something about it. Now, indeterminate, as far as Calc AB goes, we only care if we get 0 over 0 or infinity over infinity. Those are the only two we're using in this course for indeterminate. Okay, and it simply implies that the limit cannot be determined and there has to be an additional analysis of it. So there are other indeterminate forms. These just don't appear on our AP exam. 0 times infinity, infinity times negative infinity, 1 to the infinity, 0 to 0. We only focus on these two. Okay, so hold on one second, Dree. So in Unit 1, like we said, if we got 0 over 0, we went back and factored. They factored for us here. These cancel. We get x plus 6 over x plus 4, and then we resubstitute the 4 in to get this limit. However, this method's great if you can factor, but what if you can't factor? When if you have something like this in there, an e to the 2x, okay, and you can't factor, there's another method, and this is where it comes in, and this is really useful in trig, and it's called L'Hopital's theorem. All right, and what it says is if, let me highlight this, because this is actually, I have to write it up on the exam. If the limit of the numerator equals 0 and the limit of the denominator equals 0, then L'Hopital's theorem says just take the derivative of the top and the derivative of the bottom, and then apply direct substitution. So if the limit of the top is 0 and the limit of the bottom is 0, aka indeterminate, you can derive the top, derive the bottom. Notice I'm not using what rule?
Quotient.
It's not quotient rule. This is the one time, Luke, you are allowed to not use quotient rule.
I'm not the quotient person. That's great. I'm proud.
Yeah, that's me.
That's you? Oh, you're the product rule. That's right. This is a one time where you're not going to use quotient rule. You're just going to derive the top, derive the bottom, and then apply direct substitution again. Now, if you get 0 over 0 again, you would take another derivative. Typically, it happens 1 or 2 times. It really doesn't go past that. I mean, it could in theory, but it doesn't necessarily have to. So let's apply a few examples. This is super easy. Number 1, I'm going to substitute in 4. Now, every limit is not L'Hopital, right? It only happens if it's 0 over 0. Was this the same question?
Yes.
Let's not do the same question. Let's jump to example 2. All right, let's plug in our 0. So I get e to the 2 times 0, so that's e to the 0. Anybody to the 0 is 1 plus 0 minus 1, which is equal to 0. On the bottom, I get 0 plus 0, which is 0. So I get indeterminate. Okay, so I don't have to use this factor, multiply by the conjugate. I don't have to do anything fancy except apply L'Hopital's rule, which says take the limit of the numerator and the limit of the denominator. So the numerator, e to the 2x, that's e to the udu, so e to the 2x times 2, plus the derivative of x is 1, minus the derivative of 1 is 0. all over x squared plus 4x becomes 2x plus 4. Now I'm going to reevaluate my limit. So if I plug in 0, I get e to the 0, which is 1 times 2 is 2, plus 1 is 3. 2 times 0 is 0, plus 4 is 4, and the limit is 3/4. This is an extremely handy rule, especially when it comes to trig. I'm not going to remember this rule for those of you that took a full year of pre-calc. I can try, but I really don't remember because I just never memorized these in my life. You learn like rules for like sine x over x or 1 minus cos x over x. Do you remember these? Now you're supposed to cancel to 1 or to 0 or something. You never have to memorize those rules because you have L'Hopital, which just says when you get indeterminate, take the derivative of the numerator and denominator. So I've never talked about those rules because I have never used them in my life. I just use this instead. All right, let's look at this first example here. Example 3. The limit as x approaches -2. So I'm first going to evaluate the function. I'm going to find f of -2 minus 1. 2 times -2 is -4 plus 4. All right, what is f of -2? 1. 1 minus 1 is 0. I get 0 over 0, indeterminate. So now my brain is saying, go use L'Hopital's rule. I'm going to take the derivative of the numerator and the derivative of the denominator. So f of x minus 1 just becomes f prime of x minus nothing. And 2x plus 4 just becomes 2. Now I reevaluate that limit. I'm going to plug it back in. So now I want f prime of 2. So now I'm looking at the what here? The slope. What is the slope of this line? -1/2 divided by 2. If you can't divide that in your head, think of like a keep change flip. I can say that's -1/2 times 1 over 2, or -1/4. So L'Hopital's rule, wonderful rule. You're going to use it a lot in the course, but it only works if you get 0 over 0. What happens if you get 0 over 4? It's 0. What happens if you get 4 over 0? Does not exist. Can't use L'Hopital. The only time I can use L'Hopital is if I get 0 over 0.
What if we can factor it? Just don't, would it work still if we use
Oh, yeah.
L'Hopital?
Yes, it'll still work with L'Hopital.
Okay.
And you can factor. You can go either one. Again, this is going to come in useful like when it's ease or trig, things like that. Or these types of functions. Let's try another one here. The limit as x approaches 4. So I first have to evaluate it because it may not be a L'Hopital question. G of 4 looks like, does -3 sound right? All right, if I plug in a 4 here, 4 times 2 is 8, 8 minus 8 is 0, e to the 0 is 1, so I get plus 3, all over 4 minus 4. I am getting 0 over 0. Okay, so now I'm going to use L'Hopital. The limit as x approaches 4. All right, so now I'm taking the derivative. G of x becomes g prime. Oops, that should be plus. 3 is a coefficient, so that's going to say e to the 2x minus 8 stays. So that's e to the u, and then times the derivative of the u is just times 2. And then 4 minus x becomes -1. Okay, and then we're going to re-evaluate the limit. G prime of 4 looks like -1 plus 3 times e to the 0 is 1 times 2. So I get 6 minus 1. I think I'm getting 5 over -1 or -5. Do we all understand the rule? Only if we get 0 over 0. All right, grab your card, and let's put L'Hopital. I'm probably saying that wrong. I know you don't say the S. Dre, I'm disappointed that you're not all over this.
I would prefer Spanish, not French.
Ugh. All right, so L'Hopital's rule. All right. Forgot they make you write this funny on the exam. It's a short answer. All right, if the limit as x approaches c of f of x over g of x equals, what's the only thing it can equal? 0 over 0. Then you take the limit as x approaches c of f prime of x over g prime of x. Okay, and I'm going to put repeat. You repeat until you get an answer. So if you got 0 over 0 again, then you repeat the derivative again until you get an actual answer. Maybe I'll put can repeat. Okay, you can repeat that process. I totally forgot. So you'll usually see this in the multiple choice. I'm going to stick this on here. If it's a short answer question, they call that free response. If it's in the free response, this is just super annoying. They don't give you credit for writing 0 over 0. Okay, so if this is a 3-point question, they give you 0 on it. You have to specifically say the limit as x approaches c of f of x equals 0, and the limit as x approaches c of g of x equals 0. Which you feel like you're saying by doing this, but they said that's not credit. You actually have to write this out separately. Then you can take the derivative of both. I agree. This was like a new rule 2 years ago that they said they're not giving credit for, and then they keep asking it over and over. So I'm just sharing the rule, so you get credit. Okay, so if you see 0 over 0 and it's multiple choice, you don't need to do this, right? Just take the derivative of the top and bottom. If it's in the short answer, you got to write out the top and bottom separately is all it's saying. All right, stick that in the ring. And then, so the questions that go with this, I think there's only 8 questions. Page 153, 154 here. Now again, I just want to stress, if you don't get 0 over 0, it's not L'Hopital. Take your time to plug the value in to see if you get that. But there's just some old multiple choice free response. You got 5 minutes, you can probably crank out a good amount of them.